show at the International Architecture Biennale in Rotterdam. We were accepted. And they will be part of this large exhibition that will go from April to August this coming year. The project is called River Cities. We look at a different river city each year. Hopefully over 10 years we've looked at 3 now. This year we're looking at a necklace of cities in northern Kentucky, Covington, Bellevue, Newport, etc. But these will all be exhibited there. I'm going to go over this very quickly. You know where Rotterdam is. The last thing I'll show, just kind of energy related, is really cool. You have great color. We have a great sense of color. We didn't do this. This is what happens when you let Dutch people mess around with websites. We are participating this year with the first American entry in a competition that's been going on now for 5 cycles. It happens every other year. We are the first American entry to this, and we will take about 10 students to Rotterdam and do the competition. The competition is for innovative uses of concrete and cement. And this year the focus of the competition is on energy efficient uses of concrete and cement, alternative products. And we'll actually kick this off next week with a lecture on Monday night by a guy named Gregor Zimmerman. He's a PhD in structural engineer, actually. He has a company called GTEC, and they're working with a lot of really freaky, weird, interesting, and amazing new concrete products. But we're going to do a workshop with them next week to kick it off. And then the students will go over in October, and they'll enter this competition. Is that the last image? Yeah, it seems to be. If it's not, it seems it is. If it's not, it is. Just want to say one thing in closing, just about design and about this business of innovation that I alluded to earlier. If you go back to the solar decathlon competition we did, we generated an enormous amount of knowledge, and we have since developed a series of products that we hope become commercially available and hope will have an impact on the Commonwealth. But one of the important things that design education, I think, has to offer is that, in my view, it's a really important engine of innovation. And it is because of 2 things. One is almost all of our work is team-based. So we work in studios with 12 or 15 students, all of whom are working together on projects. They also have to consult as professionals with engineers, with marketing people, with developers, with a whole variety of people. So the work is intrinsically team-based. It's also public. They learn everything in public, and when they present their work, they present it on the wall in public for public review. It's a very public and team-based kind of learning process. The other thing is, and this is really important, and I know engineers do this too, but it's absolutely the alpha and omega of design and design education. We work by prototype thinking. By that I mean you give us a series of constraints, and we produce what ifs. So what if these were the constraints? It has to be green, it has to be on this side, it has to be this material, it has to cost this much. This is what it would look like. And the importance of that is that prototyping doesn't just give you an answer to what it might look like, what it might be like, but it's a way to generate an answer. But that answer is an answer, especially if you use a lot of these 3D digital fabrication technologies. It becomes a way for you to prototype a possible solution, sit around, have a discussion about it, redesign it in a very iterative kind of process. And what that does is not only generates the possibility of getting to a better design solution, but it also generates a body of knowledge. Because every time you make a prototype and it's not right, especially if this is done using digital technology, it's captured. What you do is you build up a kind of a whole knowledge base of successes and failures, and you use that in projects going forward. So very often, the solutions that you have that are right, that turn out to be the right solution, are not always the innovative ones. They're the ones that are wrong, that come up in projects later. So this idea of prototype thinking is extremely important for us. And it's really how we went from the sort of decathlon house to the HDR units. It's how we transferred that knowledge and how we continue to prototype and create things along the way. The big revelation of all that is that design is no longer literally about this thing, this piece of designed object that's at the end of the design process. It's instead about all the knowledge that's generated through the prototype process itself. So design really is no longer simply about this, it's about design knowledge. That, I think, our students are beginning to understand fully, and I think it's important not only for architects, but it's important for engineers as well. That's all Michael will speak about, unless you have questions.
What's going on with the solar decathlon house now?
I think it's over, they have transported it over, I think it's by the agriculture, it's over kind of the agriculture campus. I think Don Colliver has it over there doing something with it.
It's in front of Barnhart.
What?
It's in front of Barnhart.
It's in front of Barnhart. Don is sticking pins and needles in it and testing it for stuff going on.
It has solar panels on top of it, right?
It does, yeah.
So could it be producing power for the...
It's supposed to be. It's not hooked up right now. But the idea originally is it was off the grid. We generated all of its own power.
Could it produce power for the university?
Did you look outside
well,
today?
Not for a fan. Not a lot. You wouldn't want to use a hairdryer in here. It was off the grid. It produced all of its own power, and and you could sell, theoretically it could be sold back, to the grid, but it's not hooked up right now. It is over there. Yes.
What kind of technology?
No applause. No applause. Yes.
What kind of technologies was used from, or were used from solar decathlons for those houses that customers?
Well, everything from very, very welding and just basic stuff to we used in our college all of our CNC machines, the routing machines. We used all the laser stuff. It was all design. All the design work was done digitally and was output with prototypes and with models using the fabrication stuff we had there. So just the whole kind of array of digital fabrication output technologies that we have, CNC, all that stuff.
Did you have to train?
Sorry?
Did you have to train the employees?
Well, the software acquisition is an interesting sort of question and problem. We don't really teach classes in software. Typically, a studio will use a software and students just kind of have to pick it up. So we don't really teach software in any of our studios. There's some softwares we teach, like Revit, but we don't typically teach the design softwares. They're more often just, Marty Summers actually similarly has taught a number of the Henderson studios and can tell you that most of the people just have to pick it up. Also because many of the softwares that our students use for this and in a lot of early adaptations in design schools, many of those softwares came from other industries, like from the movie making industry, for example, or from car manufacturing. And all of the tools and techniques that were efficacious there didn't really make as much sense for us. So we kind of would pick, students kind of pick and choose the way the applications work, or the way they adapt. They're not always the same as as they're using other industries. Yes.
What did you say the power requirements were for the modular housing, the target design?
The target design was $1 or less per day to heat and cool
For the entire community?
for the whole house. That's provided they don't use plasma TVs and that's a kind of a cultural issue. I'm an offender as well. I have two big TVs. But we are not at we're at about $1.60 per day. And the reason for that is when we first made the $1 per day or less claim, we had arrayed the houses in a neighborhood design, and we're taking advantage of things like geothermal